Given a triangle in R3, I'm going to show how you can use vectors and cross products to find the area of the triangle. Suppose we have this triangle. Point 1 will be x1, y1, z1. Point 2, P2, will be x2, y2, z2, and point 3, of course, will be x3, y3, or z3. And let us call that the height, and let us call this an angle. Now, I'm going to call this the base, which is vector u, and I'm going to call this over here vector v. So that's the angle is between vector u and v. Now I shouldn't say b equals u. I should say b equals the length of u. B represents the length of the base. Okay. So now we know that the area is 1/2 b times h. And we know that b is the length of vector u. And we know what 1/2 is. We know what we're going to call b. What are we going to call h? Well, if you think about it, the sine of the angle between u and v is the opposite divided by the hypotenuse, which is v. So maybe I can say it this way. H is equal to the length of v times the sine of the angle. So with this notation, I can write the area is 1/2 times the base times the height, which is v sine theta. And that's a times, not a dot product. Okay. So the area is 1/2 of that. But that is nothing more than the length of u cross v. That's what we just proved in the last video. So if you just multiply the lengths of u and v, you can, and take half of that, you now have the area of a triangle. And again, u is just the base and v is just one other side. So it's just half of u, the length of u cross v. That completes this video. You now have a new way of calculating the area of a triangle in R3. Can you modify this rule to find the area of our triangle in R2? Think about that.